SI notation, SI notation. So update your table of contents. Notice your page number might be different than mine. Woo. Am I doing this right? I'm doing it right. So it's 2 pages of notes. So SI notation has to do with prefixes. It's a shorthand engineering notation. So you can go review the engineering notation. This is on my iPad, so all these extra things are coming up. Hopefully nothing inappropriate comes up. So that's a group math chat, not that you care. SI notation, it is French. It stems from the French, and I'm going to butcher the pronunciation, but to the best of my knowledge, is Système International d'Unité, which means International System of Units. And there's a value. Notice, if you stop the video and think about it, which is always a good idea, the values are what's so special about the exponents. That's right, they're multiples of 3. These are only some of the ones that exist, but they're the ones we will use in digital electronics. So I just need you to know there's more of them out there. There's a prefix, and this is if you're talking to somebody in this shorthand language, this is what you say. Yeah, and then there's a symbol, and that's what you write. You can't go rogue and like make your own things up like, oh, I don't like capital T, I'm going to use little t. No, then nobody's going to know what you're talking about. You have to do the capital or uppercase and lowercase as they are. So what you say is, and repeat after me, tera, giga, mega, kilo, milli, micro, nano, pico, and femto. So a little faster. Tera, giga, mega, kilo, milli, micro, nano, pico, femto. And yes, we're going to have to memorize them and come up with some memory tools. This is what you write as a prefix. They're pretty self-explanatory. Eventually, you should know that the capital T goes with a 12. Come up with a memory tool. And this weird one over here, that's a Greek mu. You have to have the tail. It's a lowercase mu in the Greek alphabet. You have to have the lowercase, this little tail. It goes below the line, and then it looks like a U. Mu. I have some examples of the correspondence between either SI notation and engineering notation. I guess that's all I've used. And you can see the back and forth. So I might write these down and then take some time to understand how did I get there, yeah? Again, do the future you benefit? Yeah, help the future you out. Stop and think about stuff, otherwise it's not going to stick in your head and it's kind of a waste of time for you. All right, now this, so I'm planning on, we're going to start this in class. You're going to just look at these notes and then you're going to fill in this table, but later on you're going to go back and write these notes. You need these notes for future reference. You'll use them a lot, both pages. I have a 4x4 table of numbers. I've given you the ones in yellow, and you're supposed to convert them to all other forms. So I've given you one of the forms, and you're supposed to convert them to the other 3 forms, and it goes across. So like this 5, 6, 7, 8, 1, I would put in scientific notation, then I would put in engineering notation, then I would put in SI notation, yeah? Similarly for the second number, this guy, then the third number, then the fourth number. Yeah, you don't need a calculator. These are just units we'll talk about later. And here's your workspace. So hop to it.